So is everything okay? Um, so everyone, thank you. Uh, my scheduled chair, she came to attend the board meeting. So I have to chair this session myself. So it doesn't matter. Anyway, let's begin. Um, for this session, we'll will present the theory part of the BGP Watch platform. And for the next session, we'll focus on the hands-on training. So this session will focus on theory part of the training. For this presentation, I will first give a brief introduction of the project overview, and then I will present the hijacking detection algorithm behind the system. How we design the algorithm and how we implemented them, and then we will talk about the functionality of the platform, and then I will show some work we have done on BGP routing, sharing, and looking glass platforms. And finally, I will play a video on how to use the platform. This work we have done by a collaborative community. We have 19 teams here, and partners, they have done hard work, and yeah, thanks them for their hard work. For the first phase of the project, we started in 2022 and ended in 2023. And we get a foundation from Epinic Foundation from about $150,000. And for Tsinghua University, they give in-kind contribution about $70,000. For the extension project, we started just in the December of 2023 and will end in June of next year. This is an ongoing project, and we welcome new partners to join. This is the website of the project, all the information about the project and the partners information and the documents and the news. You can get all the information in this website. So first, I will give some introduction on the hijacking detection algorithm. All we know that BGP hijacking often leads to catastrophic consequences. There are mainly two kinds of hijacking. The first one is prefix hijacking, and the next one is path hijacking. I think all our engineers know this well, so I won't dive into the detail. For the BGP hijacking solutions, there are three types of solutions. The first one is preventing the hijacking before it happens. There are RPKI, we all know, and SPI. All the engineers and researchers have done some work on this work, but RPKI is still in the process of deployment. The second type of solutions is to monitor the routing information and to detect the hijacking. There are root views and repositories. They get route information and provide research data. And there are some platforms for BGP hijacking detection, such as BGP Stream and Grip. The second type of solutions is to mitigate the hijacking. Often this work will be done together with monitoring and hijacking work. When there are BGP prefix hijacking events occurs, usually there are malls. We will find malls that are multi-S numbers that claim to be the origin of the same prefix. Usually, malls is a critical characteristic of source hijacking, but it's not solely caused by hijacking. There are some other events, situation which will cause malls, such as multi-homing, traffic engineering, DDoS mitigating, and anycast address. All this will cause malls occur. So determining the legitimacy of malls is a major challenge. We use rules combined with machine learning method to solve the most filter. Firstly, all the BGP route information. Yes, the BGP route information, we get the information and we analyze, we get the false and we test multiple. And also we train using ground truth and with some information from ROI, RR, all this information to training machine learning classifier and then all the potential hijacking events will be filtered by this machine learning classifier and find the potential source hijacking. Here we have some rule-based filtering, such as first we will build with ROI filter information, and then we will and then we filter with all the provider and customer information, and then the filter and also we build with some other means, such as they have same administrators. All this information we sync with who is database, and also we filter it with frequency and duration filters. For the ROI data synchronization, the ROI data, they change frequently. Usually we can see that every day, this is the data from one day. Some prefix are moved from one S and then registered by another S. So all this data we sync very, very frequently. About 5 minutes, it will be synced. For the machine learning based filtering, we use the features including mode type as rank difference, business relationship, geographic relationship, announcement activity, hijacking activity, and edit distance of S name, organization description, and S type, degree and cornice of S, and prefix type. And all this information are used as features to training the machine learning classifier. And finally, we get a higher precision. The next, we will talk about S-pass based on link, S-pass fake S-pass based on link prediction. Because S-pass hijacking will cause unseen S links. We use a hybrid plan detection technique. We treat all unseen links appearing in the control plane as suspicious event, and then validate the event through the data plane programming. But there are unseen links are very common. So it will cause a higher load requirement for the data plane. So the idea for us is to evaluate the authenticity of unseen links with link prediction and filtering the benign unseen links. Such as on this graph, there are some links we haven't seen it, but it's actually exists. So the link prediction algorithm will to evaluate the probability of a link if it will exist. So there are some research on link predictable method. For unseen link classification, we use SEAL as the link prediction algorithm, and we use CADA-S relationships and some information as the training data. We train with positive and negative samples. The accuracy reached about 55%. This link predictor, we use to train it, use reliable links and multi-source data, and so we get the data set and train it, and we get the link predictor. This is the framework for the S-path detection, S-path hijacking detection. It is based on unseen links. It's combining link prediction and rules. And the link prediction, the picture feed, we get it, and we get the S-link, new S-links, and we evaluate it. First, we use some rules, and then we use the link predictor. We just training, and then we get the result. This is the result of the accuracy, some test in the test environment. So there are many. This is a huge amount of writing data from root views, RAIS, and PCH, and also our platform. So to improve the system, we use the parallel computing and cluster systems to get all the data. All the data we process and we send to Kafka, and then there are some consumers to process them and get the final result. Besides the basic hijacking detection algorithm, we evaluate the time level of the events for the if prefix, it has many prefix. There are many websites in the prefix. Then we will evaluate as a higher level events. If it has about a little few websites, domain name in the prefix, we will evaluate as a mid-level events. Otherwise, we will evaluate as a low-level events. For each event, for each hijacking events, we give the prefix information and the website information. For the websites, to get the website in the prefix, we get the top 1 million domain from Twinkle and Cloudflare. We get all the data, and then we convert the domain name to IP through lookup, and then we can link the prefix with the domain name. So for S type, we get the we know some S type maybe it's a cloud or hosting many sites. We will think this as all these prefix are important. So we get the S type information from this website. This is a SDB, is a research database that maps AS number to organizations and to the types. So we use this data to correspond to link S to the S type. Now we have open source this data. So this is the link. You can check this link and get the source data. And we welcome more partners who will join us, will contribute to the project, so we can improve the project better and better. The next part, I will introduce the functionality of the platform. This is the first page of the platform. We can get the some summary information of the hijacking events. In the middle, there is a map we can get, which can know get all the hijacking events from which to where. And for the left column, there are some statistic information from which country and which type. For this is a real-time hijacking monitoring platform. We can see all the events here and the type, the level, the event information, the S and the country information, and the prefix, and the time of the information. You can download the information. And also you can search the S number, prefix, other information here and get the information you want. Also, we evaluate the level of the events. You can get the level, the basic information and the prefix and the website information. Also, the platform can respond quickly, and it is about 5 minutes delay, and it have event replay, so you know how the events occurred, and it support comments from users. Also, users can subscribe hijacking events for their S numbers, and then they will get an alarm email, such as you can subscribe your information. This is a hijacking. You can get this is the email tell you there are potential hijacking events. This is a statistic information for anomaly events. You can get the overview data events information. Also, you can search by your country, by your S number, and you can see yearly, monthly, and weekly all the statistic information. We compare with some other platforms such as Grip. We think ROI data. This is ROI data. We think with ROI data very almost real time sync with the ROI data. So for these events, we can see that for the ROI, this as they have registered this prefix. So when we detects the hijacking events, we will judge. Think this is the victim, and this is the 834 is the hijacker, but not for the grip platform. They don't check the ROI data, so their events is violate with ROI data. And compare, there are some other platforms I think we do. Firstly, we have a quick response time, and we have event replay, and we have statistic information, and we have event level evaluation, and we have benign Morse report, and we have email alarm. And we think our accuracy is a higher, higher accuracy. Also, we developed some tools to help the network operators to diagnose, to monitor their network. We have a dashboard. Operators can see their S information, prefix, and peers, all this information. Also, they can do routing search to see aggregated forward routing paths, and reverse routing paths, and bi-direction routing paths, and also they can subscribe in and get alarming information. This is the site you can. This is open. This platform is open, so everyone can access them and use them. This is a dashboard. You just input your S number or your organization name. You can get the information, and then you can get the prefix status information and detailed prefix information. Also, you can get your peers information. This is in the dashboard. Here is the key neighbors, and also you can get your all neighbors information of your S. Also, you can search routing paths from any S. You can select an S, and then you input an IP address. So when you input an IP address, maybe there are some subnet work and supernetwork of it. The system will search all the subnetwork and supernetworks of the prefix you just inputted, and then group the prefix. So from this picture, we can see that some prefix that share the same paths. So this is helpful for the network operators to know their network better. And also, you want to know, sometimes you want to know how traffic was sent to your network. So we have reverse routing paths. You can input your prefix, and you can see how a traffic from another S was routed to your network. You can search at scale, input the S number. Also, we provide by routing paths search. For this example, the left is a prefix from Terry, and the right is a prefix from learn. And we can see that the forward routing paths and the reverse routing paths, they are not the same. And you can monitor the path change from one S to a prefix. When there are some changes, you will get an email. Also, you can see that the routing path changed. Just one S is omitted from the path. The path just you can change it to just one hop from 3 hop to the destination. So this is helpful to the to the operators. Also, they can monitor their prefix change, their peer change, all this information. You can help them get more information. Also, you can monitor the router changer. Routers sometimes some routers will announce and withdraw a prefix frequently. So we monitor this situation, and there are some top prefix that are announced and withdraw frequently. Also, we provide open API. Also, we just provide 2 open API: get the hijacking event by condition, and get event detailed. You can get the detailed information from our website. We have a detailed document and video on how to use all these tools. And then I will talk about a platform we just established for BGP routing sharing and looking glass platforms. We all know that BGP routing collections are very important. There are some vantage points, very famous routing collection vantage points, such as rivalries and root views. These are the points distributed in the map, but we also know that the vantage points in where Asia region is still remains scarce. So we hope that in our community will work together to improve the coverage of the routing collection vantage points in our Asia area. So we have just established a BGP session collaborator platform. Now we have 15 partners. You can get the information from this website. This is our collector information. If you are interested, you can contact with us. You can peer with us with this information. Also, we know that looking glass vantage point is useful for our operators. Also, there are some looking glass pages that we can use, but there are still many looking glass that are we haven't know. So we try to find more looking glass vantage points. For a web-based looking glass, you can input your command, and then the looking server will send the command to the router, and then send back the information to you. This is our website. We have connected with several partners, and also we did some links to some partners. For this platform, we use open source. The configuration is very simple. We get here some samples here, and you can get the detailed information on this website. Many partners will have the security concerns, such as where are the data are stored, will our data be stealed, or some kind of things. For the data stored, we use for the sharing platform. We all store them in the cloud server, the Singapore or Hong Kong. All the data are stored on open cloud servers. And some partners may ask, will peering with your routing collector will harm our network? Actually, we use the open source to simulate a real BGP router. It owns the send routing announcement and all the information, root views, and drive. They all are famous sharing platforms. So it owns hurt your network, and you can contribute to the community by doing this. Some partners may ask that say that our security policy doesn't permit SSH and telnet access from other networks, and we have some alternative solutions such as single ring. They use a VM to simulate a router and pair with their real router. Then our looking glass can access the VM and get the route information. For the future work, for the second phase of the project, the objectives is first develop an integrated looking glass platform, and the second is to use this looking glass to further check the routing hijacking at the data plan. And then we will develop a path hijacking detection and routing leak detection, all these functions. And we will continue to maintain and fix bugs in the BGPWATCH platform. And we will continue on the community development. All this work we started in the December of 2023. And for the training work, community development, we hosted the training with Apan57, and we will participate the Apricot and TNC conference. And also we plan to open source the project, and now we have opened the project, and all our we hope all partners or communities will join us to work together to improve all the systems. We have found over 2,000 vantage point secure the obscure looking glass platform. All this platform we have opened. We have developed another system that where all the looking glass vantage point we found, we integrated them here. You can get them each point. You can use anyone, search and use them. And we based on this platform, we will develop an open API and open source them, so provide to partners to use them. For the data plan detection, because we know that now we just do the hijacking filtering in the control plan, but in the data plane we can do more, because we can detect from the vantage point, from all the looking glass vantage point, to check if it work, if when a hijacking occurs, it will affect the service. So we can check if the service is working okay. If it's working okay, maybe it's not a hijacking. It's just a load balance or engineering, traffic engineering. This is the most main part of the systems. So I hope maybe I will play the video first, and I can if any partners have any suggestions or comments. So comments or suggestions first, then I will play the video. Sorry.
The public at https://bgpwatch.cgtf.net. This platform supports BGP hijack detection, ensures swift response times, sends event warnings via email, assesses the severity of events, and provides event replay capabilities, which are all designed to effectively assist network operators. Additionally, the BGPWATCH platform, under BGPWATCH, BGP Events Monitoring and Diagnosing Platform Project, has been developed by researchers and engineers from 19 countries, economies and funded by APNIC Foundation and the Chinese government. The partners include ARNet, Apan57, BD-REN, CERNET, DOSTASTI, ERNet, HARNet, ITB, Crayonet, Learn, MyRen, NREN, PERN, RENS, SINGA-REN, TaiRen, Transbac, University of Surrey, and University of Göttingen. The platform is accessible to the public at https://bgpwatch.cgtf.net. This platform supports BGP hijack detection, ensures swift response times, sends event warnings via email, assesses the severity of events, and provides event replay capabilities, which are all designed to effectively assist network operators. Additionally, the platform has developed various tools useful for network operators to monitor the network, including a dashboard displaying the key AS information, showing forward, reverse and bidirectional routing path, and supporting subscriptions. This video is an initiative of step-by-step demonstration of the available features in the developed platform of BGPWATCH. Now, let's check it out. In your browser, you can put the URL of this portal. The URL is bgpwatch.cgtf.net. So this is our homepage of this portal. First of all, we're going to register and log into this portal. On the top right corner, you'll see a button called Register. Click on this Register button, and you'll see 4 fields to fill out: your username, password, confirm password, and your email address. Let me put my username as manual testing. Then the password. Let's put a secure password. Confirm my password. And the email address. Let's consider this as our email address. And this is our fill out form. Click on this register button and you can see that registration is successful. Click OK to get out of this pop-up window. Now that my registration is complete, I have to confirm my registration by clicking on this link that has been sent to my email address. Let me check my email, and here we can see that we have an email from sec@cgtf.net. And this is the link to verify our email address. Click on this link and it'll be redirected to the portal again. You can see that with my manual testing, I have logged into my account. So this is the process of registering yourself and logging into this portal. You can also sign out from this system by clicking on this sign out button. And also logging in manually with username and password, manual testing and our password, click login. And you can see that I have logged in with my username and password. So that concludes our registration login section. Now we have logged into the system. Let's check out this homepage. In the homepage, you will find an input field for selecting your preferred time zone and a date fetch picker calendar. Depending on the range selected on this calendar, you'll see a statistical information about the BGP hijacking events and information about the hijack victims and attackers. Here you'll find two pie charts expressing the name of that attackers and victims, countries or regions. This is an interactive chart. You can click on this legend to show or hide statistics of any of these countries or regions. Let me click on this unknown button. This hides the statistics from unknown countries and regions, and the rest of the figures of the countries are automatically redistributed in this pie chart. You can click on this expand button to enlarge this section for a better view. On the right, we have IPv4 and IPv6 prefix bar chart. Along the x-axis, we have the prefix length, and along the y-axis, we have the hijacking event counts. You can see that if I hover on my mouse on top of this 24 prefix, in the selected time period from 11th of December to 21st of December 2023, you can observe that there are 283 BGP hijacking events for 24 prefix. This is the statistical information of the hijacking events for IPv4 prefix. At the bottom, we have the similar information of hijacking events for IPv6. Again, you can click on this expand button for enlarging this section for a better view. In the middle, we have a distribution bubble map of victims and attackers. Here it is a global map for the countries or regions, where the number of victims and attacker are portrayed. The green bubbles are showing the victims, and the red bubbles are denoting the attackers. The pilot lines with animations of directions are showing the hijack path from the attackers to victims. If you hover your mouse, you can see the attackers. Here is the United States, and hijacking given count is 167, and you can see that Canada is the victim here, and the hijacking event count is 2. This pilot line is showing the attacking direction. You can click on this expand button to pop this window up. And for a little bit of enlargement, you can also click on this plus or minus sign to zoom in or zoom out this map. This map shows the BGP hijacking events that's been going on in different regions of the world. At the bottom left, you can see there is a pie chart for the possible hijack, ongoing possible sub-hijack, ongoing possible hijack, and possible sub-hijack. Here you can see the possible hijack count for the selected time period is 311, ongoing possible hijack count is 25, ongoing possible sub-hijack is 15, and possible sub-hijack count is 2. Here you can see there is a line graph of the day-wise event count of possible hijack, possible sub-hijack, ongoing possible sub-hijack, and ongoing possible hijack. All of this event counts in a line graph. Here you can see along the x-axis we have the dates, and along the y-axis we have the count of their events. If you click on these legends, you can hide or unhide any of these lines. If you click on any of this line, you can see that for a particular day or a particular time. There are 31 possible hijacks, 0 possible sub-hijack, 0 ongoing possible sub-hijack, 0 ongoing possible hijack, and total number is 31. So all of this information provides us about the statistical information and an overview of the BGP hijacking events that's been going on all over the world. That's all for the homepage section. Now let's check out the anomalies section. In the anomaly section you'll find two subsections, overview and anomaly. Let's check out overview first. The overview section shows the global hijacking event count in a configurable time period in a bar chart. The bar chart shows the possible hijacking events, the possible sub-hijacking events, and combining all of these events for the last 12 months. Here you can see along the x-axis, we have the name of months, and along the y-axis, we have the count of the events. The bars are denoted by the colors shown in the legends. The blue one shows the possible hijack. The green one shows the possible sub-hijack. And the yellow shows the 3 events. You can filter and change this bar chart in 2 ways. First of all, the time duration. You can filter for the statistics of last 7 days, or last 30 days, or last 12 months, or for the years, like 2022, 2023, or all of this data. You can also change the periodicity of the bar chart. You can click on daily to view the possible daily hijacking events. It can be selected as weekly, monthly, or yearly. The data in this bar chart are showing the global possible hijacking events. You can also select any country from the drop-down menu. Toggle to the as number mode to search with your desired as number statistics. Let's say we want to show a particular country or region's BGP hijacking data. Let's select Asia, then Bangladesh. Here you can see that the bar chart shows the possible hijack victim, the possible sub-hijack victim, the possible hijack attacker, possible sub-hijack attacker. All victims and all attackers count along the y-axis, and the periodicity like daily, weekly, monthly or yearly is shown along the x-axis, which we can change it from here. Now if you click on any of these graph legends, you can hide or show any of the information in this graph. You can save this information as CSV by clicking on this Download Data CSV button. Here you can see that the data has been downloaded. Now if you hover your mouse on top of any of these bars, you can see that the number of all attackers in Bangladesh region for August 2023 is 23. You can also hover down your mouse here and you can see the victim count in August 2023 is 15. As you can see, there are 2 information in the same bar. If you want to go into details of this bars, you can just click on this bar and you will get details for the month of August 2023. You will see 4 weeks for the statistics of month August. As you can see, the format has been changed to the weekly format. And if you click on this weekly chart, the week 32 will be expanded into a day-wise format of that week. As you can see, this has been shown in the day-wise or daily events. Now if you want to go into more details of any particular date, you can simply hover your mouse on tops of any of these bars and you can click on the link Go to Anomaly. Details for the anomaly part will be covered in our next session. In the anomaly subsection, you'll be able to see a table that displays the information about the BGP hijacking events going on all over the world. Here shows you the information about the event types. It can either be possible hijack, possible sub-hijack, ongoing possible hijack or ongoing possible sub-hijack. You can also see the levels of harm. It can either be low, middle, or high. You can see the event information like the victim's name and number, the hijacker's name and number, the number or the count of prefixes that has been hijacked, the prefix that has been hijacked, the start time, and the end time if the hijacking has been ended, the duration of the hijacking event, and a link to the details of the hijacking event. You can filter this event by event type. Let's say we want to see the information only conclude the possible hijacking events with a high level of harm. For the time zone, let's say GMT+6. For the time period, let's take it for the month of November of 2023. Select November 1st till November 30th. Hit OK. You can also add more filters. If you want to filter on the criterion for possible hijacking events having a duration of more than 3 minutes, you can simply click on this toggle button. You can see the duration has gone greater than 3 minutes. You can also search on this table with a wider area of filtering, like AS's country or region or his name. Let's say we search for HK, then we will be able to see the records containing the strings HK in event info. That means the information that contains Hong Kong is shown on this table. Also, if you click on this value of the prefix number column, you can see that the system shows the list of the prefixes or the sub-prefixes that has been hijacked. Here's a download button. You can download all information in CSV format by clicking on this download button. Then you can further analyze this information in your own way from this CSV. Now let's move into the details of this events. Here, you'll be able to see the hijacking event details. This page shows you information about victims and hijackers, victim country and victim description, hijacker country and hijacker description, normal prefix, start time of the hijacking event, end time of the hijacking event, time zone and duration of the total hijacking events. Following that, you can take a look at the reasons why it is labeled as a possible hijack event. The reference sources to determine it's a hijack event or not are from ROA and WHOIS information. And the underlying algorithms were written to find and compare the registration information of the prefix with the corresponding ROA and WHOIS information. If the registration information of the prefix is found and matched the information here, then it will be labeled as a good reason shown in the green blocks. If the registration information could not be found from ROA and WHOIS information, or didn't match with the corresponding information, it will be labeled as a warning reason shown in the orange blocks. In this case, 4 reasons are listed. 2 reasons present the prefix information does align with ROA and WHOIS information, which are shown in the green blocks. Another 2 reasons state the prefix does not align in ROA and WHOIS, which are shown in the orange warning blocks. Here is showing the prefix info again, and the websites under this prefix. Next, we move into the event review section. In this section, you'll find the information about the reverse routing path of the victim, and the hijacker during the hijacking event in a time-stamped manner. Here you can use this slider to move into different timestamps to get this information. You can also press this play button to autoplay this section. As you can see, the system is going to the next timestamps automatically. You can pause the play button and go to the start of this event. In the example here, this part is showing the reverse routing path of the victims 140227. If we go to the next timestamp, we can see that this section is also showing the reverse routing path of the victim is 140227. It is also showing the traffic from these ASs are going towards the hijackers 32519. These ASs failed to find their destination to the AS 140227. The following timestamps are showing the change in the reverse routing path in different time frames. If we go to the last timestamp, this is the reverse routing path of the victims after the hijacking event has finished. If you hover your mouse on top of any of these as numbered nodes, the system will show you the information about the AS number, AS name, country, and the organization name. At the right side of the event review section, you will find the comments section. You can check whether the hijacking event is intentional, or by mistake from the site users' comments and voting. Here users can see acceptance and reject ratio in a pie chart. The users can add comments, place your accept or reject votes by clicking on this Add Comment button. Click on this Add Comment button, you can vote as accept or reject, and put your own comment in here like, "This is a hijacking event." Click OK and this comment will be visible to the global site users. As you can see, the pie chart is also changed to the acceptance status. That's all for the anomaly section. The dashboard section provides information about the ASs. The dashboard section is comprised of 4 tabs: the basic information, IPv4 peers, IPv6 peers, and WHOIS. First of all, there is a search option where you can put your desired AS number. Based on your search, you will find the IS country or region of the IS number, the IS name, and the IS organization. Below that, you will be able to find the IPv4 prefix count of Cernet. Here you can see a line graph with a day-wise prefix count of the last 7 days. It also shows the minimum and the maximum count of IPv4 prefix that has been originated by Cernet. Here you can see the maximum count of IPv4 prefix is 5,134, and the minimum is 5,132. Besides that, the IPv4 address size is shown in a similar line graph. This shows the day-wise count of 24 prefixes are originated from Cernet for the last 7 days. The maximum 24 address size here is 163,447, and the minimum count is 163,435. At the right side of that, you will be able to find the IPv6 prefix count and the IPv6 address size 48 prefixes count, which shows the similar information that are displayed in the line graph of IPv4. Also, you will find a bar chart on IPv4 prefix count. Along the y-axis, you will be able to find the count of the prefix, and along the x-axis, you will be able to find the prefix length. As you can see, for 20 prefix originated from Cernet, the count of the prefix is 1248. The similar information is shown in the IPv6 section in a similar bar chart. Further, you will see the highest or tallest bar here is 32 prefix length, where the prefix count is 4,190. At the bottom of this page, you'll be able to find a table that shows the IP prefix list that have originated from the selected S here. You can filter this list with your selected bar available in the bar chart above. Let's say, if you select 20 from this bar chart, you will be able to see the list of 20 prefixes in this list. As you can see, the total number of 20 region prefix is 1248. And if you click on this IPv6 bars chart, let's say in 48, you can find that there is 1612 prefixes of 48 notation is shown. You can also toggle this table into all mode by clicking on this toggle button. It will observe that the table or the list is being replaced with all of the IPv4 and IPv6 prefixes of all length, with a total count of prefixes originated from the IS 4538 Cernet. You can also apply search on this table. Let's say, if you want to search a specific IP address starts with or contains 110.6, it will show you the list of IP prefixes with your desired numbers. All of these listed prefixes are hyperlinked. If you click on any of these prefixes, you will be redirected to the reverse routing path topology page of that prefix, which we will cover in details in Routing Paths section. That's all for our dashboard, the basic tab. Now, let's move to the IPv4 Peers tab. In this tab, you will find a connectivity diagram of IPv4 BGP neighbors or peers of selected AS. Let's search for 63961. Hit search. You can see that the AS 63961 has different types of BGP neighbors. We have provider, peer, customer, and unknown. You'll find that the blue ones are denoting the providers. The providers to AS 63961 are 17494, 132602. We have peers denoted by the color orange, and you can see it's AS 9885. We have customers denoted by the color yellow and is displayed in many yellow-colored nodes, like as 138382 is one of the customers to AS 63961. Here, we can see that there are two types of lines. The pink-colored lines are denoting the exports, and the blue ones are denoting the imports. As shown in the pink lines, AS 63961 is exporting and advertising its prefixes to its providers and peers. The blue lines are denoting the inputs. Here the 63961 is importing or advertising prefixes to its customers and peers. You may found that on top of each line, there is a number, which denotes the number of prefixes that the AS63961 is importing from or exporting to. As you can see, the AS63961 is exporting and advertising 79 prefixes to the AS17494. On the right side, you can see there are 4 pie charts. The first 3 pie charts are present different IPv4 contents but all based on the number of imported and exported prefixes. The first pie chart shows the top 10 IPv4 providers for the AS. The second one shows the top 10 IPv4 peers. The third one shows the top 10 IPv4 customers. And the last one shows the peer country distribution. Like others, these pie charts are interactive. You can click on any of these legends to show or hide any of this information from the pie chart. In the bottom, you will find a table that shows the BGP neighbors, which contains information of AS number, organization, country or region, AS customer cone, the relationship with the neighbor, the number of the selected AS prefixes that is exporting, and the number of the selected AS prefixes that is importing. You can also filter this table by clicking on these checkboxes. If you want to show only the provider information, then check on the provider checkbox. If you want to show all of the neighbors' information, just click on all to show all of the BGP neighbors of the selected AS. As you can see, each of these rows is showing the BGP neighbors information. Now, let's go to the IPv6 peers tab. This tab shows the similar type of information as shown in the IPv4 peers, except the BGP neighbors are the IPv6 neighbors here. As you can see, they're providers, peers, customers, and unknown. Same as IPv4, you will find similar types of for pie charts with the similar types of tables, with filtering facilities as shown in the IPv4 tab. The next tab is Who is tab. Here you can check the registration information of AS numbers. Those information are collected from Regional Internet Registry, RIR. Depending on the registries that AS registered with, here is showing the corresponding information. In this case, 2 sources of registry information are displayed for AS63961, which are from APNIC and RITE. For the example of CERNET, there are 3 registration information displayed here: AFRINIC, APNIC, and RITE. The registration information are different with registry organizations. Basically they include the registered holder, description, AS country, organization, contact information, etc. Here sums up the dashboard section. Now, let's check out the routing paths section. BGP uses both forward and reverse routing paths to determine the best path to take for the data packets to reach their destinations. Routing paths section is actually comprised of 5 subsections: routing path, reverse routing path topology, bidirection routing path, and jitter route. Let's start from the routing path. Here you will have to select the NRENs or organizations as the source from the list, such as Apan57, ARNET, BDREN, CERNET, FIDI, HARNET, ITB, CRAYONET, LEARN, MyREN, NREN, PERN, RENS, SINGA-REN, TIREN, and TRANSPAC. For our destination, we can put any prefix or IP address in this search bar. Let's consider Apan57 as our source. And we put an IP address or prefix for the destination. Hit search. We can see that the system is returning all the subnetworks and supernetworks of our input prefix. The networks have different lengths like /17, /19, /20, or /21. Which are shown on the left. This illustrates the fine-grained routing feature. The left shows that some networks share the same routing path, and they're grouped with the same color. If you click on this same colored block of prefixes, it will show you the path for the first IP block. And if you click on this second block, the path for the second block will be shown here. Now, if you want to search with an IPv6 address, you can input an IPv6 address as well. Let's consider we want to see a forward path of the prefix shown in this example. Let's paste it in here. We can see that here the system is also returning the subnetworks, and selected networks have this /32 input prefix. We have /40, /35, /32, etc. If we click on any of this colored notes, this shows the first colored block. This is the second colored block for this path. This shows the third colored block. And this shows the fourth colored block. This concludes the routing paths section. In the reverse routing path subsection, you will have to put an input prefix or IP address in the field up here and hit search. The system will search the best match prefix for your input and show you the reverse BGP routing tree of the prefix that you're giving. Let's take a look at the system is displaying. This is the reverse routing tree for this prefix. In most cases, this is going to be a very large tree, but you can scroll left or right to view the full tree. In this case, as you can see, the prefix 1.0.128.0/17 is under AS23969, which is advertising the prefix to their upstream and so on. So this is how the tree has been formed. Now, let's move to the reverse routing path topology. This subsection gives us the same information as the reverse routing path, but this is shown in a more concise space and a topological format. Same as the reverse starting path. It takes an IP address or prefix as an input, and the system will search for the best matched topology to reach the prefix from the outside world. Let's consider the prefix here. As you can see, the system has a complete reverse routing tree for the input prefix. In this graph, the notes are actually the AS numbers. They are in different colors and in different sizes. At the bottom right corner, you will find a legend for the color nodes. Now, if you want to see a reverse part from a note to the starting prefix, let's take this node. Click on this node and you can see that the system is showing a reverse routing path from the node AS20080 to AS58453, to AS4538, then to the starting prefix. You can also plot the reverse starting path for the selected prefix from a desired as number by a searching. Let's consider we want to put AS3170 to the selected prefix. This will plot the reverse routing path from the desired AS to the starting prefix. You can also modify this graph by hiding this part up to the layer, or show any layer back again. You can do this by clicking on this legend. If you click on this layer 5, the layer 5 nodes will be removed. And if you click on this again, the layer 5 nodes will be added again. But if you click on this layer 2 legends, all the layers up to layer 2, that is layer 3, layer 4, layer 5 will be removed. You can click on these layers one by one to bring them back. Also, you can click on the remotest layer to get back all the layers on the way to the selected prefix. That concludes the reverse routing path topology subsection. Now, let's move into the by routing path subsection. In this section, you can find the forward and reverse routing path from a source and a destination IP address or prefix. The left and right IP address in the input field can either be IPv4 or IPv6. This is very much similar to the subsection routing path, except the routing path is bidirectional here. There is a search box at the top of this page where you can put an IP address or prefix at the left IP. And at the right, you can also put an IP address prefix in the search field. And this will give you both the forward and reverse routing path. Let's consider a prefix here as our destination and put our right IP in here. Do the search, we can see from the path from left IP to the right IP. The forward path is shown in here, and the reverse path is shown below. You may found that the forward and reverse routing paths are actually different, even for the same two IP addresses but acting different roles as the source and the destination. Next, it's jitter root subsection. In this section, you can find the top prefixes and peers that have most jitters. Our sources are listed on the left. Click on the ASN list. We have such as Apan57, Arnet, BD-REN, Cernet, etc. On the graph,
okay, I think it's a little longer. On the website, we have put in schedule, and you can get the website and the link to the video, and you can check the menu and the video. Yeah, so we left some time for some comments and questions. So anyone? Some suggestions? Welcome. So also there are the link. The link also you can get the link here. Or in the schedule, the app, you can get the link, get all the information. Yes, YouTube, you can get it also. We may set the YouTube link in that schedule. You can add the YouTube link to the schedule. Yeah, we also have a YouTube link. Yeah, we hope more people from our community will use the system and the feedback, give us the feedback so we can improve. Next session is the hands-on session. You can try the system and we'll be here to help you if you have any questions. So, anyone? Any question? So if no question here, can we take a picture quickly here? Thank you.